Hello, let us now try to understand the bitwise OR operator. But before that, as you can see, I have retained that function print binary here as well that we have developed in the last tutorial. So we'll be using this print binary function henceforth to print the binary configuration of any signed integer number. That will be helpful for our understanding. So if you are applying any bitwise operator on any variable, then you can just check what happened there with that variable by calling this print binary function and passing that variable. You'll be able to see the bit configuration there on the screen, and you'll be able to analyze your thoughts. Okay, let's now go ahead and try to understand the OR operator, bitwise OR operator. Here you can see that I am just applying that OR operator with x and y, and the result is assigned to z. Now let us analyze this situation. X is 10, that means the content of x, if I write only the least significant 8 bits, 1010, and the content of y is again least significant 8 bits. Now if we are applying the OR operator with x and y, then each bit of x will be ORed with the corresponding bit of y in the same way as we ANDed x and y. So here it's the OR operation. So we'll start from this. 0 or 1 is 1, so the result is 1, and 1 and 1 is 1. Here we'll have 1. 1 and 0 is 1, so we'll have 1 again. 1 and 0 is 1, so we'll have 1, and all the rest of the 32 bits are going to be zeros because we have zeros for x and y for both of them. So this is going to be assigned to z, so the content of z is going to be something like this, or exactly like this. So least significant 4 bits of z is all ones, and that is actually 15. So we can just go ahead and run this program and see if that is correct or not. So let me just clean the screen and run the program. So here we go. So you can see that it happens in the same way as we analyzed. So the least significant 8 bits are 00001111 for z, and the value is 15. Now the usefulness of this bitwise OR operator is that we can set a particular bit to 1. If that is 0, we can turn it to 1, and if that is 1, we can retain it as 1. That means if you want to change a bit from 0 to 1, then you can use the bitwise OR operator, and that's the usefulness of this bitwise OR. So if, again, I'm just reiterating, if you want to set a bit, a particular bit, if it is 0, you want to set it to 1. If it is 1, you want to retain it as 1, then you can use the bitwise OR operator. Let me just give an example. Say x is 10, so it's 0, 0, 0, 0 and 1, 0, 1, 0. So I want to turn this particular bit to 1. And I can just apply the bitwise OR operator, keeping 1 at this particular point. That means at 2 to the 0, 1, 2. So at 2 to the 2, if I just keep 1, then, and if I just do the OR operation now, you can see that all the bits, since here we have zeros, so all the bits here will just drop exactly as they are. So all these will be zeros and ones exactly as they are there for the x. So we'll have 0 here, we'll have 1 here, but this particular bit is going to change because we have 1 here. So 1 and 0 is 1, so this is going to turn out as 1. Now if we have something else, say we have 0, 0, 0, 0 and 0, 1, 0, 1, and we want to set this bit to 1 if it is not 1, and if it is 1, we want to retain it as 1. So if again I'm doing the same thing, I'm ORing that particular x, say this is x, with 4, then you can see that everything for the x will remain same. All these bits are going to remain same because we have zeros here, so ORing with zeros will remain same. Will not change all the values there for x, all the bits there for x. So this is 1, this is 0, but you can see that this is 1 and this is 1, so this is going to retain as 1, and all the rest of the bits are going to remain as it is for the x. So this is how this works. If you want to retain a particular bit as 1 if it is 1, and if it is 0 you want to turn it to 1, then you can just use bitwise OR operator. So let me just go ahead and change the program and show you this particular thing. Okay, I'll just keep x as it is, and then I'll just print the bit configuration of x. So print binary x will print the bit configuration of x, and then I'm going to do this x or say 4, then you can see that 4 is 2 to the power 2. That means that index 2 will actually now be 1. Again, I am just calling the print binary for x to see what happens with x, and we don't need all these things. Give a new line between the call of print binaries, otherwise all bits are printed in the same line. Okay, now let me go ahead and compile and run. You can see that here for the first bit printing, here the second significant bit is 0, but that is 1 right now. So that's how the bitwise OR operation works. Thank you for watching.